Hello students, this is Professor Dr. Moina Akhtar Mughal. I'm a professor in Dr. M.A. Qazi Institute of Chemistry, University of St. Jamshoro. So I was telling you about identifying an organic compound. If you have been provided an unknown organic compound, how you are going to identify it via different steps. So there were basically 4 different steps. Today we are going to start with the 4th step, that is the melting point of your organic compound. Every organic compound, as I've told you before, has a different specific melting point, and through which, via which you can identify its you can say its identity, right? So what is, first of all, you should know what is the process of melting. The process of melting, right? You should first have some idea about melting. When you take out your ice cube tray from the freezer, okay, it has the ice cubes in it, fine. In the freezer, when you take it out, the temperature is minus 30 degrees centigrade, whereas your room temperature is 25 degrees centigrade. How this change of temperature is related to the melting of the ice? This is the question. Temperature is also, you can say, called heat energy, right? It is also called heat energy. As temperature increases, more is the heat energy. If more is the heat energy of the particles, this heat energy is converted to which energy? The kinetic energy, right? This conversion of heat energy of particles to kinetic energy, and as kinetic energy and speed are related, very much related. Greater is the kinetic energy of the particles, greater is the speed. More the temperature and more the speed. Now, and greater is the speed and vice versa. For example, if lesser the temperature, lesser is the kinetic energy and lesser is the speed. So now, simply what happens that during melting we have ice, a solid at, you can say, minus 30 degrees centigrade, right? Temperature of water at room temperature is minus 25 degrees centigrade. So we can observe increase of temperature. There is an elevation, you can say, of temperature after heat has been provided to the ice. The heat converts to kinetic energy, or you can say, greater the kinetic energy, greater the speed of the particles. So as you know, when the therm or heat is provided to anything, the molecules, they start vibrating among themselves, and the vibration of the molecules, it becomes so fast, they start colliding with each other. The collisions are so vigorous, they are so strong that the intermolecular space between the particles gets lesser, and as the intermolecular phase gets lesser, their space between the particles becomes lesser, resulting intermolecular force between them, it decreases. Therefore, they overcome the force of attraction, and so the solid from form converts to the liquid state, and this is how the process of melting takes place. Now let's walk you through again the process of this melting. As temperature, as I told you, increases, or as we provide the heat energy gets converted to kinetic energy, thereby increasing kinetic energy of the particles, resulting into speed of the particles. As the particles move more vigorously with this higher speed, they move away from each other, resulting into the, you can say, spaces between each other, and increase in the interparticle space, decreasing the interparticle force, you can say, of attraction, and converting a solid to a liquid. And this is how the process of melting goes on. So now what happened? What could you can say be the melting point of ice? In freezer, the melting point of ice is minus 30 degrees centigrade, whereas it changes to water, it becomes 25 degrees centigrade. So let's check melting point of the ice. Is it minus 30 degrees centigrade, 25 degrees centigrade, or 0 degrees centigrade? Now, if we perform an experiment, for example, take some ice cubes in a beaker and arrange a thermometer at the top of it, right? Just we do it in the lab, right? And start heating the heating the beaker that contains the ice cubes. Now you can see the temperature change in the thermometer, just which is pointing towards your face, right? As we heat the temperature from minus 10 degrees centigrade rises to 0 degrees centigrade. At 0 degrees centigrade, the entire ice converts to water. This is it. So from the experiment, we can observe ice melts at 0 degrees centigrade. So this could be the melting point of the ice, as ice melts at 0 degrees centigrade. So this could be the melting point of that ice. The melting point is a constant temperature, you can say, at which a solid melts to become liquid at a atmospheric pressure. Let's walk through the experiment again.